All right, IM3 classes. Today we are talking about the logarithmic function and giving you an introduction to what a log is. Let's get into it. The definition of logarithms, they're the inverse of an exponential function. Basically what this means is, have you ever seen an equation where the variable is in the exponent? So something like 5 to the x power is equal to 600. And you're wondering, how would you go about solving that? You would use logs, all right? And this is what we're going to be building towards. We are going to be using logs to solve an equation like this, but there's a few things, introduce you what logs are, how to put them into calculators, and different properties of logs before we get into the actual solving of logs and exponentials using logs. First thing what we're going to be doing is rewriting exponential equations as logarithmic equations. Basically what I want you to notice here, so this would be the equation in exponential form, so b to the x is equal to a. To write it in logarithmic form, what you do, if you take a look, the exponent and the a kind of switch spots, right? And then the base of the exponential becomes the base of the log. So these are switching spots, all right? And then the base of the exponent becomes the base of the log. All right, so let's look at some of this is. So 3 to the v power is equal to 72. We're going to write it in logarithmic form. All right, so the v and the 72 are going to switch spots. So the equation is going to be equal to v. The base of the exponent becomes the base of the log. So this is log base 3. And then the 72 goes here. That's it, right? So here, again, these switch spots. So the equation is going to be equal to -20. The base of this becomes the base of the log. So it's log base b of a. All right? Again, the b and the a are going to switch spots. So the equation is going to be equal to the b. And it's log base is 13 of a. All right. Let's go towards do other ones. So again, these are going to switch spots. So the equation is going to be equal to x. The base is going to be the base of the exponent, and then it's to the y power. All right. So again, these switch spots. It's equal here. The base is x. The exponent becomes 16. All right. Again, these switch spots. The 12, it's equal to 12. Here's the thing, there's something I forgot to mention. If there's no log or if there's no base on the log, this is log base 10. All right. And we're actually going to talk about that in a second. I put that a little early. But so this is going to be 10 to the p power is equal to 12. And might as well talk about that now. So if it's log, say log of x, all right, we would say this is log base 10, all right? The number here, so if it is log 3 of x, this would be log base 3 of x. There's one more log, it's called the natural log. The natural log is log base e. We'll talk about the number e later in class. It's something we kind of skipped over a lesson talking about e's, but I'll talk about the number e later. But these are all different logs. So this is log. This is a base 10 log. This is base 3, and then this one would be log base e. Again, I'll talk to you more about what e is later on, but that's all we need to worry about for today. Moving on, just using a calculator to approximate these. So real simple, so again, this is log base 10 of 46, this is log base e. Your calculator should have these buttons on there. So let me bring bring up a calculator. So the first one is log of 46. I'm going to do the log button. 46 is equal to 1.6627, something around that, 1.623. So 1.6623, no, 1.663. That's what it was. The ln is the natural log. So again, there's a button for that on your calculator. It might be, depending on what your calculator is, you might have to push a second to find it, but there should be an ln. When you're in class, just let me know and I can help you find that if you need to. So ln of 67 is 4.204. So let me make sure I'm sharing my screen. So 4.204. And then we'll do one last one. ln is 77. Natural log is 77. So that's the ln button, 77. That is 4.344. We'll round it to 4.344. So that should be pretty easy to approximate with a calculator. All right, so here, evaluate these without a calculator. These can be tricky, but sometimes it's easier to think about this if it is termed in terms of an exponent. All right, so let's say this is equal to some number x. I'm going to rewrite this as an exponent, so an exponential form. So remember, these switch spots. So the exponential form is going to be 64 base 4 the x. So 4 to what power is equal to 64? And you can guess and check here, but that's 4 cubed is equal to 64. All right, so that means that log base 4 of 64 is equal to 3. All right, so whatever, if you think about in terms of an exponent, you can figure out what this log is. So again, think of this as equal to some number x. Rewrite it in the exponential. I think it's easier to think about. So that's the x becomes the exponent. So it's going to be 6 to what power is equal to 36? Well, that's 6 squared is equal to 36. That means over here, log base 6 of 36 is equal to 2. All right. So this one here is a similar thing. You're just thinking of it as 8 to what power is equal to 64. So 8 squared is 64. So that means log base 8 of 64 is equal to 2. And that is all you need to do on those. So those take a little practice, kind of wrap your head around how to think about those. That's how we do those. Oh, and then we're back to that first slide. Yeah, that'll do it for today. We'll do more properties next time. So we'll see you then.